Alright, and now for the other example, we would like to consider if we integrate along a vertical path here from z equals to 3 plus I to z equals to 3 plus I. 3 plus 3I rather. Okay, so as usual, one would write the equation of the straight line y is equals to mx plus b. However, in this sense, does it make any sense, okay, to do so, because this is a vertical line, and the change, the gradient is undefined, so we cannot write the equation this way. Instead, we have to flip it the other way around, and then we shall have to write the equation in the form y is equals to my plus b. X equals to my plus b. Okay, so it will look as if we have flipped over the axis, okay, and such that here we have y and here we have x, and x is fixed at that, while this one here ranges from 1 to 3. In other words, here we shall have I plus 3 up to 3I plus 3. Remember, this is the imaginary part of z, the real part of z, and this is the imaginary part of z. Okay, so like you can see now, our x, even if we actually don't write x equals to my plus b, we simply see that x is, the slope is 0 for this one, and x is just fixed. This one here is 0, and x is just b, the intercept, which is 3. In other words, x is just, you can see that it is just the value here on the vertical axis here, the x in this case is just fixed at 3. Okay, then it is our y, which we shall parameterize this case and then say is equals to t. Therefore, our x is equals to, x is already 3, we have written it, and y is equals to t. Therefore, our z, which is simply x plus iy, and if you want to parameterize it, z of t equals to x of t plus I y of t. What is x of t? It is a constant, then plus I y of t. Y of t is t, so that is our z of t. We can get z dash of t, which is 0, and then this is I. So we know that the integral of our path, this path here, we shall call it C2, okay, over this path C2 of f of z dz. C2 f of z is z dz, integrate from t. Now t is taking on the values 1 to 3, okay, which were the y values from y to 3, of f of z, which is z, and what is that? F of z, which is 3 plus it, then zt, z dash, then dt. And what we have now is the integral from 1 to 3i. Then this is I squared times t, that is minus t dt. So we have 3it minus t squared over 2 from 1 to 3. So upper limits, we have 9i minus 9 over 2. Then the lower limit, we have 3i plus 1/2. So 9i minus that gives us 6i, then 4 minus 4.5 plus 1/2 minus 4. So you can just arrange it, and then we say it is -4 plus 6i. Okay, great. Now we are going to summarize all this by writing this. So we had different paths. Okay, we had a first path here. Okay, we had a horizontal path. We also had somewhere a vertical path, and then we also had this path here. So the first path, C, okay, we had 1 plus I, and this was 3 plus 3i. This was 3, this is 1, this is 1, and this is 3. Okay, then the next path, C1 was this path here, where we moved from 1 plus I to 3 plus I. I hope you, okay. And then lastly, we have just seen this vertical path, 3 plus I to 3 plus 3i. This one here, 3 plus I to 3 plus 3i. So we integrated along all those paths. And then for C1, for the path C, we found, let me just get it here, we found the integral to be 8i. Then for path C1, we found this is 4 plus 2i. We had 4 plus 2i. And lastly, for this path here, C2, we have found it to be -4 plus 6i. So we say that regardless of the path here, the answer should be the same. So when we integrate along the path C of our function f of z, okay, C just from here to here, it should be the same as taking the path C1 and then the other integral along that path C2. Indeed, along the paths, this is 8i, and then this was 4 plus 2i, and then this is -4 plus 6i. Indeed, this and that cancel, and then that and that gives us 8i. Okay. Alright, so I hope you have learned something and enjoyed this. So we shall look at maybe further examples just to drive the point home. So thank you, and see you in the next video.